Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at fractional indices. So let's start by looking at 2 to the power of a half. What is that? Well, you can't actually multiply 2 by itself half the time. That doesn't make any sense at all. So how is this even possible? Well, what mathematicians have done, they define this so that it's consistent with other index laws. See, the thing is that we know if we take 2 to the power of a half and square it, the power to a power index law says we keep the same base and we multiply the powers. A half times 2 is 1. Of course, 2 to the power of 1 is just 2. We don't even need that 1. But what we can do, because we have an equation, we can do whatever we want to one side of the equation as long as we do it to the other side. So in particular here, we can square root both sides, because square root and squaring, they undo each other. So on this left-hand side, I'm left with 2 to the power of a half. On the right-hand side, I have the square root of 2. So 2 to the power of a half is the square root of 2. So by similar logic, 2 to the power of a third, if I cube that, I also get 2 to the power of 1, or 2. Now I can cube root this side of the equation as long as I cube root that side of the equation. Cube rooting this side of the equation will get rid of the 3. So what I'm going to be left with is 2 to the power of a third equals the cubed root of 2. So you're probably seeing a pattern here. We can write a general statement. A to the power of 1 on C is the cth root of A. So a to the power of a quarter is the 4th root of a to the power of a fifth is the 5th root of a, and so on. But what if I wanted to do a fraction whose denominator wasn't 1? What if I, for example, wanted to find 2 to the power of 5 on 3? Well, using index laws, that's 2 to the power of a third, and we can raise that to the power of 5. Of course, it doesn't matter in which order I write these indices because I'm multiplying them, and the order of multiplication doesn't matter. So I can write it like this, 2 to the power of 5 to the power of a third. But I know that a third power means cube root. So this will be the cube root of 2 to the power of 5. So by similar logic, if I have a to the power of b over c, then the bottom number tells me which root to take, and the top number in the fraction tells me the power. This is the rule for fractional indices. So this is in index form. This is what we call in radical form. This is a radical. It just means it has a root sign. So if you had something like x to the power of, say, 4 over 5, and you wanted to turn it into a radical, the bottom number tells you which root to take, and the top number is the power of x. So if you had something like the 7th root of x to the power of 10, and you want to convert that into a fractional power, the power of x, 10, goes on top, and the root goes on the bottom. So these two are equivalent. So what if we wanted to evaluate something like 64 to the power of 5 over 6? What would that be? Well, that would just be the 6th root of 64 to the power of 5. But of course, if we don't have a calculator, 64 to the power of 5, massive number. We don't want to do that in our head. What we can actually do is do this part first. The 6th root of 64 first, because that's easy. That's 2. And then raise it to the power of 5. 2 to the power of 5 is just 32. So 64 to the power of 5/6 is 32. All right, let's now look at using fractional indices in conjunction with other index laws. So let's simplify each of these and write our answer as a single radical with a single root sign. So to perform the division law using indices, it's pretty tricky while they're written as radicals. So let's first write them as fractional powers. So cubed root of x to the power of 8. So power goes on top, which root it is goes on the bottom. And then, of course, for x to the power of 19 fifth root, 19 goes on top, which root it is goes on the bottom. So just if you've forgotten, when you divide bases, you keep the same base and subtract the powers. So to subtract these fractions, they need to have the same denominator. So I'm going to times top and bottom here by 5, because 8 over 3 is the same as 40 over 15. And then 19 over 5, I'm going to times top and bottom by 3. So I get 57 over 15. So I end up with 40 over 15 minus 57 over 15. I end up with this. So how would I turn a negative power like this into a radical? Well, we know from negative indices, we can just put it on the bottom of the fraction and write it with a positive power. So if I want to turn this back to a radical, it will be the 15th root, because 15's on the bottom, and what's on the top becomes the power. That's my final answer. All right, how about this here? Let's write this as a single radical. Well, that can be a bit hard the way it's written. So let's go and write this as a fractional index. So we'll start with the inner bit. Square root of x to the power of 7 is just x to the power of 7 over 2, because square root is always the second root. Now, when you cube root something, you're raising it to the power of a third. 7 over 2 times 1 over 3 is 7 over 6. So this is x to the power of 7 over 6, which is the same as the sixth root. So number on the bottom of the fraction is which root, and then number on the top of the fraction becomes the power. How easy is that? All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.